Hello, pre-calculus. Today we are looking at concept number 10. We are looking at the inverses of exponential and logarithmic functions. An exponential function, the exponential function f with a base of a is denoted by f of x is equal to a to the x power. So in your exponential functions, your base is always the bottom number, and then the power is what it is raised to. So in this case, your power is x. Your a value, your base, has to be greater than 0, and it cannot equal 1. If it equaled 1, it would just be like taking 1 to the 5th power would be 1 times 1 times 1 times 1 times 1, which would just be 1. And then x is any real number. Okay. The one-to-one property, this is one of the pieces of exponential functions. The one-to-one property is when a graph passes the horizontal line test. The functions are one-to-one, which means for a greater than 0 and a not equal to 1, a to the x equals a to the y if and only if x is equal to y. So this is the important part. If we know, so say we have an equation like 5 to the x power equals 5 to the 5th power. The only logical thing to do here, since these bases are the same, the one-to-one property tells us we can drop those bases and x equals 5. Okay, I'm going to go ahead and start down on the notes, just with those few things in mind. Go ahead and grab out a calculator if you don't already have one out. I do not, so give me just 1 second. Okay, exponential functions. Example 1, we are going to use a calculator to evaluate each function at the indicated value of x. So we've got the function f of x is equal to the x power. So for a, I'm going to write it over here. We want to find f of negative 3.1. So we've got 2 to the negative 3.1 power. Go ahead and type that into your calculator. That's not going to be a nice and easy answer you can do in your head. That is going to give us about, we're going to round to 3 decimals here, so about 0.117. It's 0.1166. So that 6 is going to round up to a 7. All right. On B, we've got f of x equals 2 to the negative x power, where our x is pi. So we're going to find f of pi. So we're going to take 2 to the negative pi power. Most calculators at this point have a pi button on them. If they do not, you can always use 3.14 as your decimal approximation of pi. Either way, it should get you to about that same value of 0.113. That one's going to round down. We got 0.1133. So since the 3 is less than 5, we round down. Okay, I want you to go ahead and try C on your own. Okay, hopefully you got about 0.465. Since it was 4647, that 4 is going to round up to a 5. Okay, so that's just a basic exponential function. Next, we're going to look at solving using the one-to-one property. So that one-to-one property, we needed the same base. So right now, we've got 3 to the x plus 1 power equals 27. Those don't have the same base yet. We can force them to have the same base because 27 is 3 to the 3rd power. So we're going to rewrite it. 3 to the x plus 1 equals 3 to the 3rd power. And then since these bases are the same, they are both a 3. That means we can drop those bases off, and it becomes x plus 1 equals 3. From there, simple algebra, subtract your 1 from both sides, and we have that x is equal to 2. Okay, be just a little bit more complicated because it's not as straightforward. So there's a couple ways you can do this. Most of the time, people will rewrite 1/2. So we've got 1/2 to the 2x minus 1 power equals 32. Most people see immediately that these can both be written as a base of 2. So 1/2 is the same as 2 to the negative first power. You just flip that over the fraction bar. And then 32 is 2 to the fifth power. So using that, I'm going to rewrite this question. So we have 2 to the negative first times that 2x minus 1. Oh, it didn't erase what I thought it was. 2x minus 1 power is equal to 2 to the fifth power. From there, nice and easy algebra. Since our bases are the same, we can drop those off. And we've just got negative 1 times 2x minus 1 equals 5. From here is a couple ways you can do it. I'm going to go ahead and get rid of that negative 1 since it's in my way. And we've got 2x minus 1 is equal to negative 5. Add 1 to both sides. 2x equals negative 4. Divide by 2. I ran over a little bit, but that's okay. X is equal to negative 2. All right, so that's your basic just exponential function and then the one-to-one property. Let's go back over to definitions for just a second. The natural exponential function is f of x is equal to e to the x power. So e here is a number. E is called the Euler's number, Euler's number. You'll hear it called different or said different ways. All E is, you can find the button E in your calculator. It's usually connected to an ln, which we'll talk about in a little bit. E is about 2.718. So it's kind of like a pi. It's the same idea, just assigned to a number. So whenever we talk about the natural exponential function, we are talking about f of x is equal to e to the x power. Now, come on back over to the notes. On example 3, we're going to use a calculator to evaluate f of x is equal to e to the x power at each of these values of x. So I'll give you a minute. Just type these into your calculator. If you cannot find that e key on your calculator, find a teacher, or if there's a Tiger tutor in there, find them. They should be able to help you find it. But go ahead and solve these four and find e to the negative second, e to the negative first, e to the 0.25, and e to the negative 0.3.